Thank you very much for pronouncing a very long title. And thank you very much for attending this session. These are our conflicts of interest. The periaqueductal grain is a brainstem area that's indicated to be involved in both storage and voiding of urine. And previous work by our group has looked into the columnar organization within the PAG, and we have found that in response to electrical stimulation of the detrusor muscle, there's a clustered increase of activity in the ventrolateral region of the PAG. In this image, this is indicated in blue. And the current study aims to look into the organization within the PAG in human subjects. And we do this by investigating changes in dynamic conductivity within this region related to bladder sensations using 7 Tesla fMRI. In this ongoing project, so far we have scanned 5 subjects. And for this methodological development, we have evaluated data from a single subject. We acquired 3 resting state scans for each of our subjects. And from these 3 scans, we could delineate 5 sensory time points. The first scan was started with an empty bladder, and this was the empty bladder sensory time point. Then the next scan was conducted during filling of the bladder. And during this scan, patients were asked to communicate their experienced level of bladder fullness and desire to void using a joystick that they could control from the scanner, and we could observe their responses from the operating room. And this allowed us to separate this scan into 3 different sensory time points, which was sub-threshold bladder filling, first sensation of bladder filling, and the first desire to void. And then once the participant indicated a strong desire to void, we started the last scan. And on this last scan, we parcellated the PAG, and we did this by identifying the PAG and the anatomical images from our subjects. We then drew a personalized mask of the PAG, and we put all the voxels within this mask into a square connectivity matrix that was then parcellated using the Leuven module detection algorithm. And this algorithm clusters together voxels that have a high correlation in their time course with each other, higher than their correlation with all the other voxels. And then these resulting clusters we used for analysis of changes in dynamic connectivity across the different sensory time points. We found that our modularity Q value of our parcellation, and also for all the other parcellations, was above 0.4. And this is an indicator of a modular underlying data structure. And then we found that the change in functional connectivity is a function of sensory state between PAG cluster 2 and 3, in this image indicated in yellow and blue, all the way on the right, was significant. And these results indicate that activity in the PAG in a full bladder state can be subdivided in clusters, and that there is a significant change in dynamic connectivity between these clusters as a function of bladder sensations. And you can see that it's very small actually, but on the right image in the middle, it's at time point 3, this is the highest correlation, and the highest correlation matched the sensory state of first sensation of bladder filling. This study is the first study to investigate PAG activity related to bladder function in the sub-millimeter resolution, and the first to observe a modular functional organization within this region related to bladder function in humans. And our future aims are to assess the robustness of our observed modules across different states of bladder fullness, and we want to investigate differences in bladder sensation related changes in this dynamic connectivity between healthy women and patients with an overactive bladder. Thank you for your attention.
Thank you very much. I just had one quick question. So are there any issues in terms of repeated measures with reproducibility?
Yes, so this would be an issue. This is a very important issue in fMRI research of urodynamics. And we overcame this by using resting state scans. So these are long, 10-minute long scans, and these don't necessarily require repeated measures.
Are there any other questions?
I might, if we have some time for it, it's very interesting, and it might open new targets for pharmacological intervention. How do you see this aspect of your technique here?
Yeah, I think it would be very interesting to use this method to get to know more about the PAG function in humans, and to use it as a translational approach for previous research conducted in animals, and also it would be interesting to evaluate from pharmacological treatments over time as a participant or a patient experiences alleviation of their complaints.
Yeah. Very interesting.
Thank you.